This is Electric Universe Eyes, and today I wanted to talk about Birkeland currents and how the sun connects to our Earth and how the Earth takes all of these layers of energy and dissipates it across the globe, and creating our weather, affecting the crust, affecting generally the life on Earth. That's why we have life on Earth. Anyway, um, here's an image of the sun. Looks like an artist's rendition. Anyhow, think of the sun as a focus of energy that's connected to the other stars. So if you could imagine a circuit, we have all of these planets in the circuit, in the sun circuit. So if you could think of our solar model as an electrical model, and you have all of these components in the circuit. If we look at this from the side point of view here, I don't think this is the scale, but we've got our sun, which is receiving most of the energy from the cosmos. My thought is that Jupiter and Saturn are binaries, really Jupiter being the binary of the sun receiving most of the energy and giving off this big discharge plasma sheath, right? You think of it as a sheet of energy that's connecting all of these planets together, but it's in rings, so there is current that is going in opposite directions, connecting these things together. It's much more dynamic than I'm explaining, and I did not prepare anything. I'm just speaking as I'm thinking, so judge me if you want to. Anyhow, this image is really cool because I see how this loops the energy together between the planets. We could see the pole of Saturn. The North Pole has the hexagonal shape on top. It's got its rings as well. We got Jupiter, the king planet, which is kind of keeping the boundary of the so-called gas giants away from the solid planets that are nearest our star. So here's Jupiter's magnetic field lines, right? The plasma torus that it generates from the energy coming in at the poles, wrapping around and creating these ring currents coming out of the planets. You'll notice there's aurora at north and south poles of planets. They call it an Io flux tube, but that would be the ring current coming around and connecting to the moons. If we were close to Jupiter, we would be a moon of Jupiter, but you could consider some of these moons planets because they're just about the size of planets. Anyhow, it's a big, giant circuit. All right. So you could look at our sun giving off this energy and how this energy comes in. This is a diagram of the Earth's electrical universe circuit. So you've got our magnetosphere. Here's a magnetosphere. The ionosphere, the middle of the atmosphere, and the troposphere, the layer we live in. Under the ground would be the telluric currents. That's why everything is always grounded in electricity, because ground will dissipate that electricity out. Check this out. If you haven't gone to earth.noschool.net, you should, because it's awesome. You can click here on Earth and you can look at all kinds of good fun things. But what I'm going to show you is the air at the surface currently versus if we go up in layers, in higher elevations. And you'll notice, and again, sorry you can't see the whole thing, I'd have to minimize it every time. But what you will notice here is that these layers increase in intensity as you go higher and higher in elevation. All right, so here's all the way down at the surface. We go a little bit higher into the atmosphere, a little bit higher again, a little bit higher again, a little bit higher again. If you can imagine this charge layer, which if you see anything from the International Space Station, you can see the atmospheric layer covering the Earth, and it is a plasma sheath. That's why we have an atmosphere. It's different gases. There's electric discharge between all of these different layers. They're double layers as well. So every time it's like a step up in charge, just like electricity. You have voltage steps, right? So where you're going to have an area where there's a neutral balance between two different very high potentials. So you'll have something that's completely opposite potential of the other, but in the middle there would be a nice boundary layer, and that's usually where you'll see the clouds that are one layer above is going the opposite direction as the layer below it. So when there is a discharge between these capacitive layers, that's where you start to see these different cloud formations and the winds wrapping around each other. So anyway, let me look at, we're going to go all the way to 10 HPA. So this is the highest level of our Earth's atmosphere. And this will show you how this current right here is connecting into the poles of our planet and connects to the other planets as well. So anytime anybody says the planets are aligning, it means something. It changes the potential energy of our Earth. And anytime the sun acts up and shoots off a CME or the solar wind hits our way, it affects the compression of that magnetosphere on our Earth, how that energy is entering and exiting our planet. So if we go back here to null school, here is the South Pole. And again, we are looking at the uppermost atmospheric layer of air or wind. All right, so you can see that it's moving in this clockwise fashion here. And you almost see a similar kind of eye of the storm rotation like Jupiter has, right? But if you'll notice, the upper portion of the hemisphere is moving also in a clockwise formation. But it's the other side of the planet, right? Moving in a clockwise fashion, we flip it over, it's moving in a clockwise fashion. But if you look at both hemispheres, this is moving this direction on the bottom, which would actually be counterclockwise. If we could look at the bottom pole now, the motion is actually moving counterclockwise, opposite of this. Sometimes when you look at this, you could see this layer right here is moving in an opposite direction, and that's how Birkeland currents move. You have counter-rotating charges. Look at the extreme difference here in this energy going in through the bottom versus the energy at the top. And if you took this and you did that same motion, put your hand on top of the globe and your other hand on the bottom of the globe and twist in the direction that you're seeing these winds move. Righty-tighty, lefty-loosey, right? So if you are twisting the bottom to the right and twisting the top to the left, just like opening a jar, right? You're torquing something open. Now, here's what I guess this is what I wanted to get to is look at the shape of the continents. And now, can you imagine that if the energy potential going into our planet was ramped up, just like you ran too much power to a capacitor, what happens? The capacitor explodes. It reaches its max potential and it has to release that energy, and it expands to release that energy out because it can't handle it, okay? So imagine in ancient times when they're describing all of these biblical stories of the earth splitting open, and there were unbelievable storms, deluges, conflagration, volcanoes, mountains melting, mountains building, all kinds of crazy, insane stories. We could go on and on for days about all the different stories. But just look at how this moves, how our atmosphere moves at the uppermost layer. And imagine squashing that down and compressing this planet with extreme power difference. If you had two different stars that were tugging at each other or had a difference in electrical potential, and all of a sudden they're trying to find charge now. And again, this isn't even considering what other planets are near us at the time. Just if we were in the middle of two different stars fighting for one, energy is being pulled one direction or another, that energy is going to go into our planet. It's going to absorb that energy and try to balance out that energy with whatever else is going on in the cosmos. So there's my little crazy speech, right? I'll go further to say, let's look at a few things here. I guess I wanted to talk about the elevation differences and something I was pointing out on my last video of the geology of Texas. Now, I live in the Dallas-Fort Worth area. I lived in Austin for about 7 years, but I've lived in the Dallas-Fort Worth area most of my life. And if you go into this topography here and look at the elevation, you can see something here. You see right here this blue portion here. So that's 340 feet. And then you have this red portion here, 791 feet. And then you have this yellow area that's lower elevation, 600 feet, and about 600 feet on this side as well. So you'll notice this ridge line right here that goes up from Midlothian through Cedar Hill into Duncanville. To the left of this is Jewel Pool Lake. It's a man-made lake, but it's a natural depression area. When you're driving on 20 from Fort Worth to Dallas and you go through Arlington and you get up to this area, you start going through some really awesome hills, and the elevation suddenly changes over here in the Duncanville Cedar Hill area. There's a nice ridge line that goes through here, and they have all of these transmission towers up at the top. You can see it at night. It just looks like a bunch of sticks of LED lights sticking up outside of this lake. The reason I'm pointing this out is Texas has every type of geological feature you can think of. But what I really wanted to point out is Dallas-Fort Worth is an area that I think was had an extreme downdraft wind, a downdraft force, or a downdraft cyclone during a major event in antiquity. And the reason I say that is in Texas, there is a fault line that runs and follows this pathway, and it goes from the border all the way to San Antonio, up through Austin, Waco, Dallas-Fort Worth, and up into Oklahoma. And it kind of splits off into Arkansas and up into Oklahoma. But if you come down here to Austin, if you've ever been to Austin, there's some amazing lakes that go through this river system here. Again, look at the elevation, 884 feet versus 1131 feet. And then we go over here and we got these Lichtenberg style mountains. And look at the rise in elevation. It's pretty dramatic. Look at this. 2,300 feet versus Austin, 557 feet, right? San Antonio, 696 feet. But you just go up north a little bit. Look at that. It goes up over 1,000 feet in elevation, okay? 930 feet, we pop up here, 2388. So this area to the left of Austin, there's a city out here called Llano, Texas, and in between Llano and a place called Fredericksburg, where are we? Here's Fredericksburg. So you can see all these Lichtenberg pattern mountains coming off, meeting. So these are like built up mountainous hills, right? Versus we've got all these other fractal rivers, right? So we've got a difference in addition and subtraction, right? Something that's adding to and something that's taking away. So if you look at electricity, it moves in positive and negative. There's going to be additive and subtractive forces there. If you're discharging into something, one side is going to have a down force pressure and the other side is going to have an up force pressure. It's going to be a sucking versus a blowing. So look at this area. This wraps up along this ancient fault line called the Balcones fault line, all right, and goes all the way up here, and you can see the difference in this elevation. Right here in the center, let's see here, this area right here, this is called the Llano Uplift. And look at the elevation difference, 1706, 1139, 1711, 1949, 2104, right? Llano's pretty high up there, and if we just drop down here, 913, less than 1,000 feet over here. And then we're jumping up 500 feet. That's not very far away. What I wanted to show you here is this spiral pattern that you see, right? You see the spiraling pattern come out, and you can see all these Lichtenberg fractals coming off here. This area right here is called Enchanted Rock, and this is the tip of this giant granite dome batholith with just huge amounts of rock. Enchanted Rock is a pink granite structure. Let's see here. You got to see it. You really got to see it. Let's look it up. Enchanted Rock. It's cool. I got a video on this too. It's a beautiful place. But look at this dome batholith here. We'll go. Look at this dude climbing on this rock. I should look at this guy too. Look, he's climbing on this stuff. Look at that. Look at this, just flat rock, and you can see it all layered. Look at this. This is awesome. Look at the tops of this. So you got a depression with some water over here, and then you have this huge dome. So it's very interesting. On top of this thing has some very awesome, interesting shapes too. It collects water, and it's got its own little ecosystem up here. Anyhow, I'm getting off task. Look at this. These people standing on this. What's my point here? What am I trying to show you here? Storms usually will be swirling around. The geology. Look, Central Texas uplift. This is what I was showing you. Enchanted Rock is right about here. Right about there. And this is just a big plateau here, and then we've got the North Central Plains, Grand Prairie area. So Fort Worth is over here, Dallas is over here. It dramatically changes geology over here. That's that ridge line that I was showing you. I'll go back. Where's that? Where am I? This ridge line right here that goes right through Cedar Hill and Midlothian. Right here. Boom. See that? So I see this as a big yin-yang swirl. This is a where it sucked, and this is where it blew. So this was pushing down, and this was pulling up. The same forces down here that were kind of pushing down were wrapping up this way, pushing down, while this area was pulling down this way and lifting up here, creating this barrier. It's kind of like a barrier discharge along this area. Again, we have all of this water, and I think all of this was wet because there's lots of mud layers coming down this way. But we have an extreme creation of ridge lines and mountainous areas going down through the southwest, through the Four Corners area into Mexico, and it hits this tip of Texas. Let's go back here and look at some of these things I'm seeing here. And you can see where this all continued over on the East Coast, but we're not going to go there right now. Look at this. So I'm going to back up. We're going to back up a little bit. Here's the Four Corners area, right? And you see this central geological swirl, and it goes just about to the middle of Four Corners is where this kind of mid yin-yang point is. If you watch the Eye of the Storm articles that I've narrated by Andrew Hall, this goes into detail what I think as well created this. Again, there's no storms like this we've seen in our time. This is in ancient times that the natives kept record of this. The Lakota say there were millions of people that lived across the lands before this heavenly war started, this cosmic war, the war in the sky, this crazy battle that was out west that killed millions of Native Americans and drove them east. Because all this crazy stuff was happening here. There were survivors, obviously, but anyway. Look at this. We got this Wyoming swirl wrapping up. We got this little yin yang here. You have this build up on this portion in this swirl, and then you have a subtractive element here and an additive element here, right? Again, you still have this added with the subtractive elements in here. And if you just merely looked at the Jupiter storms, look at these storms. Look how this just wraps together, right? And you can see how this is spinning around, and this spins a different direction. These all are intertwining. This gets pulled into this loop, this gets pulled into this loop, while this is just spinning in a giant circle. There's counter rotations inside of the rotations. So it's kind of hard to wrap your mind around it at first, but let's look at this null school map again, because again, you see how this energy is entering in at the South Pole over Antarctica, right? And the winds are wrapping around this way, but then you have the opposition here as you're moving up through the Earth circuit. The capacitance layers are different. You have a positive and a negative pole, or an in and an out essentially. So, right now this is a very small scale version of what we see on Jupiter. Look at that. There's the aurora on Jupiter's north poles. All right, so you could see how that connection is moving around. Let's just look at, can we see the aurora? Sure can. Watch this. We're going to go over here, and I know they got aurora in here. Space. That shows us the aurora. So looking kind of weak right now, but essentially this is where we'd see the aurora borealis in this area. When there is visibility chance, this is going to be in red, and that usually happens right after some sort of sun event, a CME or a solar flare happens. And then again, you see it on the southern pole as well, right? So if we go back here, okay, this is a surface winds. Right? And you can see how the pattern is moving around like this. And the winds are connecting to the earth and to the ocean below. Okay? So let's go to 1,000, 850, and you'll see them start to spread out more because you're going higher in elevation. So if you watch any of these cloud videos I post of while I'm in an airplane coming down through these multiple layers, you can see how the different layers will connect through these cloud growths. And this is what it's being pulled up to. They call it the jet stream because that's where the jets go to get faster. You go to get faster. 70. Boom. We're going way high up in the atmosphere now, and then all the way up. And I don't know. Did that help? I don't know. Did it help? What do you think? Anyway, I think the Earth expanded, and weather is driven by our sun and our electric circuit. Call me crazy. Call me what you want. Just don't call me late for dinner. Bye-bye.